In this video, we're going to be talking about adding and subtracting fractions. Now, notice on this page, I have the steps for adding and subtracting. And the first thing that you always have to do when adding and subtracting fractions is to find common denominators. You can't compare things, right, unless they're the same size. So if we think about those pies, right, that we've talked about before, if I take one pie and I cut it in half and I say, okay, I'm going to share this half, right? And I have, let's say, 4 kids where I want to share this, okay? But over here, we have maybe a family, okay, that wants to split this so that each family member has the same amount. Okay, so let's say this one was already cut into 4 pieces. Well, if I need to combine or to compare the pieces on the right-hand side versus the pieces on the left, you can only do that for sure accurately if you create the same number of pieces, right? Now you can say, okay, well, assuming that the pies are identical, which is the assumption that we have, now this pie or this piece, right, and that piece are identical to this piece and this piece. So getting a common denominator is just making sure that each pie is cut into the same number of pieces. The way that we can be sure that they're the same size is if we find a lowest common denominator, so denominators that go into that each denominator goes into evenly, okay? So let's look at the first example in A, and I just want to show you a process that you can use for finding the lowest common denominator. So what I do is I take the largest denominator, so 12 in this case, and then I start multiplying it. I say, okay, well, 12 times 1, that's 12. Does the smaller denominator go into 12? No, it doesn't. So now I'm going to go to 12 times 2, and I get 24. Does 8 go into 24? It does. So that means that 24 is my common denominator. Now, we're finding equivalent fractions where each of these need to equal 24. So what I like to do is use a strategy that we've already learned. And we say, okay, well, here's my original fraction. I need to find a fraction with a denominator of 24 that is equivalent to 5/8. So this is where we say, okay, well, 8 times what gives me 24? 8 times 3 gives me 24. If I do something to the bottom, I have to do it to the top. So that gives me 15 over 24. Now I need to do the same thing for 1/12. So I have 1/12. We need to find an equivalent fraction that also has a denominator of 24. And I do 12 times 2 to get 24. If I do that to the bottom, I have to do it to the top. And I get 2/4. So 15 24ths and 2 24ths are equivalent to 5/8 and 1/12. But again, going back to that visual, the 5/8 is a pie cut into 8 pieces. 1/12 is a pie cut into 12 pieces. Now we have both pies cut into 24 pieces. All right, so pause the video. Try B, where you're finding the common denominator, and try the process that I showed you, and then go ahead and figure out what your new fractions would be with that new denominator. All right, so again, I'm going to take the largest denominator. I have 12, and you may feel like, well, of course 12 times 1 is 12, but I suggest multiplying by 1, multiplying by 2, and not skip any numbers, because it feels like if I skip a number, that's the one I'm going to end up needing. And so just to protect myself from that, I just do all of them up to a point, right, until I find something that the other denominator goes into. All right, so 12 times 1 is 12. 9 does not go into 12. 12 times 2 is 24. 9 does not go into 24. Let's see, 12 times 3 is 36. 9 does go into 36. So I know that my new denominator has to be 36. All right, now I'm going to go set up my equivalent fraction little equation thing here, right? And I need the new denominator to be 36. So 9 times 4 gives me 36. I need to multiply the top by 4 also, and I get 1636. Okay, and then I'll do the same thing for 1/12. And I need that to also equal 36. So 12 times 3 gives me 36. 1 times 3 gives me 3. So my new fraction combination with a common denominator of 36 is this. So I now have 2 pies cut into the same number of pieces, which in this case is 36. All right, so now we're going to move to doing this within expressions with fractions, okay? Now notice, in the past, when you've been taught about finding common denominators, you've probably been told, find a common denominator, find a number that both denominators go into, and then multiply the top and bottom of each fraction, right, to get to that common denominator. Well, I presented it in terms of that process for finding equivalent fractions. So you can always set it up the way that I showed you if you're more comfortable with that. Otherwise, we can just do it directly within the expression. So I will show you both ways and start shifting away from setting it up as the equivalent fraction. But I want you to be able to link both of them so you have a couple of different strategies if one works better than the other for you. Okay, so for 2a, well, actually, first of all, let's just look at the steps, right? And we went through finding the common denominator. So as soon as you see fractions with an addition or subtraction, you have to do the denominators. Then once you have your common denominators identified, you use multiplication to create the equivalent fractions with that new denominator, which is what we just did. And then you add or subtract the numerator as indicated. So once you have your common denominator, it does not change. You're only adding or subtracting the numerator. And I will show you a little strategy that I do within my process to help myself not add or subtract the denominator. Because remember, you've just cut 2 pies into that number of pieces. And so once you have it, those pies are always cut into those same number of pieces. Okay, so I have 2/5 and 1/3. So I'm going to take the biggest denominator, which is 5, and I'm going to start multiplying. So I have 5, right? 5 times 1 is 5. 3 does not go in. 5 times 2 is 10. 3 does not go in. 5 times 3 is 15. 3 does go into 15. So that means that my common denominator is 15. All right, so duplicating the process that I just showed you in terms of using your equivalent fraction framework, I'm going to go ahead and do that. So I have 2/5, and I need that to equal some fraction with a denominator of 15. And I've got the second one, so 1/3 equals some fraction with a denominator of 15. Now, 5 times what gives me 15? Well, it's times 3. 2 times 3, because whatever I do to the bottom, I have to do to the top. So I get 6. 3 times 5 gives me 15. Have to multiply the top by 5, and I get 5/15. So those are the fractions that I'm now going to be adding. So don't stop, right? You've only done the first part here. Now we need to rewrite our expression. So we have 6/15 plus 5/15. And then here's the little step that I do to help myself remember that that denominator does not have addition or subtraction applied to it. I write my equal sign, I draw my line, and then I write my denominator, my new denominator. Now all I have to do is what's in that numerator. So 6 plus 5 is 11. So 11/15 is the final answer. All right, so now let's go over to B. And this time I'm going to go ahead, I'm actually going to add a little space here. Okay, and I'm going to go ahead and show you how you can do this within the expression and not set up those equivalent fraction frameworks. Okay, again, you can do either way, but this is probably what you've seen more in the past. All right, so I'm still going to follow my process for figuring out the lowest common denominator. So I take the biggest denominator, which is 7, and I do 7 times 1 is 7. Well, 2 does not go into 7. 7 times 2 is 14. Well, 2 does go into 14, so I know that my common denominator is 14. All right, so instead of pulling the 5/7 out and the 3/2 out, I'm just going to show my work right here, okay, where I times, and then 7 times what gives me 14? Well, 7 times 2, right? If I do something to the bottom, I have to do it to the top. And then for 3/2, I have to multiply 2 by 7 to get 14. So whatever I do, times 7. And then whatever I do to the bottom, I have to do to the top. All right, now I'm ready to do the multiplication. So I get 10/14 minus 21/14. I'm going to draw my line and put my 14. And then I go ahead and subtract. So 10 minus 21 is negative 11. And that is your final answer. Okay, so go ahead and pause the video and try the next 2 problems. You can set it up either way in terms of using that equivalent fraction framework, or do what I just did, right, in terms of showing that multiplication and the conversion to the common denominator within the problem. Either way is absolutely fine. All right, so for C, first step, right, find common denominators. So I take my biggest denominator, 12, and I start my multiplication. So 12 times 1 is 12. 10 does not go in. 12 times 2 is 24, right? 10 does not go into 24. I need more coffee. Okay, and then 3 times 12 is 36. Now notice I am looking for a number that ends in a 0 because that's the only number type that a 10 will go into. Okay, so that's what I have. That's what's in my mind's eye at the moment, finding a number that ends in 0. All right, so 12 times 4 is 48, and then 12 times 5 is 60. There's my number, right, that ends in 0. So I know that that is my common denominator. All right, so I'm now going to show the process, right, of getting or changing the denominators so that they are 60. So I have 10 times 6 gives me 60. Whatever I do to the bottom, I have to do to the top. 12 times 5 gives me 60. Whatever I do to the bottom, I have to do to the top. Hopefully you're seeing the pattern here, right? Each time your brain is seeing this, it's just strengthening that pathway so that when you encounter these in the future, you won't have to think as hard, and eventually it will become second nature because you've done it so much. All right, so I get 18/60 minus 35 over 60. Do my equals sign, draw my line, put 60, right? And now I go ahead and subtract. And in this case, I get negative 17. Now, just like any time you have a fraction as a final answer, you do need to pause and make sure that it's fully reduced. In each previous case, they couldn't be reduced. Same thing here. So that's why I haven't stopped and done anything else. But again, I just have that as part of my process that I naturally do, but you may not yet. So I want to make sure that that's a clearly stated part of the process. And again, sometimes you'll need to reduce and other times you won't, like in these three problems. All right, so for D, we need to find our common denominator because it's addition of fractions. I'm going to take my biggest denominator, and I do 15 times 1 is 15. 9 does not go in. 15 times 2 is 30. 9 does not go in. 15 times 3 is 45. 9 goes into 45. So that is my common denominator. Now I'm going to go back and I'm going to create fractions with those denominators. So times, 15 times 3 gives me 45. So I need to do that on the top also. 9 times 5 gives me 45. So I need to do that on the top. Now I get 6 over 45 plus 25 over 45 equals, draw my line, write my denominator that I found. And I always say, if you put in all that work to find your common denominator, don't make it disappear, right? Keep using it. So, and again, that's just saying that we have a pie cut into 45 pieces, right? Once the pie is cut into 45 pieces, it's always cut in 45 pieces. All right, so 6 plus 25 is 31. And that's another fraction that cannot be reduced. So before we end, I'm going to scroll back up here and remind you that you have these steps, right? Make sure that you use them as a map. So for this first one, right, the 2/5 plus 1/3, I would go to my steps and I would say, first step, find a common denominator because it's fractions with addition. Then I move to the next one, right? Use multiplication to create equivalent fractions with the new denominator. All right, that tells me that I need to move to this process, right, where I pick the biggest denominator and start multiplying until I get to a number that the other denominator can go into. And then I move to add or subtract the numerator as indicated. And remember, to reduce the chance of adding or subtracting the denominator, I do equals, line, place the common denominator, and then go ahead and add or subtract the numerator, whichever one it's asking me to do.